Please open up your notes to section 7.3. In this section, we're going to be studying similar right triangles. And to start things off, we have theorem 7.5, similar right triangles theorem. And this says, if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Some key words in this theorem. First one being altitude. And an altitude is a line or line segment drawn from the vertex of a triangle to the opposite side, and it's perpendicular with the opposite side. So right here, CD that I'm highlighting in blue, that is the altitude. It is drawn from the vertex of the right angle to the hypotenuse, which is what this says, to the hypotenuse, and it's perpendicular, which means that CD is an altitude. So remember, an altitude is drawn from the vertex to the opposite side, and it's perpendicular with that opposite side. So it goes from vertex C to the hypotenuse AB, and it's perpendicular there. So if the altitude is drawn to the hypotenuse of a right triangle, so our right triangle here is triangle ACB, and the altitude is CD. The theorem goes on to say, if we have that, then the two triangles formed are similar to the original triangle and to each other. If we look at that picture there, triangle ACB, when we draw that altitude, we now have three triangles. We have the original triangle ACB, but then we also have ACD and BCD. And according to this theorem, it says all three of these triangles are going to be similar to each other. So triangle CBD is similar to triangle ABC, triangle ACD is similar to triangle ABC, and triangle CBD is similar to triangle ACD. So what that means is, if they're all similar, that means all their corresponding angles are congruent and all their corresponding sides are proportional. Okay, the next thing in your notes is that if-then proof. We're going to skip over that, and we're going to go straight to example 1. So example 1 says, identify the similar triangles in the diagram. So we need to identify the similar triangles, and we're going to write a similarity statement. Now, this is something that students typically struggle with in terms of writing a similarity statement, because you have to make sure that your corresponding angles are in alignment. And I have one way that I use to make sure that my corresponding angles are always in alignment whenever I'm looking at these similar right triangles. This is the way that I always do it. You're free to use another way, but whenever I'm doing it, I always approach it in this manner. So we have the original triangle here, triangle HGF. So we have triangle HGF, we have triangle FJG, and we have triangle GJH. Hopefully you all see all three of those triangles. Now, notice I don't have a similarity statement up yet because I don't know which angles are corresponding. Okay, and this, once again, is something that students struggle with. So if you struggle with it, I highly recommend you go through the process that I go through. So we have three triangles, and so I draw three right triangles. And I always put the right angle in the bottom left corner. It does not matter what the triangle looks like up here in the picture. I always just draw three right triangles with the right angle in the bottom left. Now, this first triangle is always my original one. Triangle HGF. The right angles are in the bottom left. And then this triangle here, we'll have this triangle be triangle GJH, and this triangle be FJG. So, triangle HGF, the right angle is angle G. So I place that on there first. So there's one vertex placed. Now, H and F, in this original triangle, it doesn't matter where I place them. H goes here, F goes here. That's fine. You could have those flipped, and that would be fine also. Okay, in the next triangle, we have triangle G, J, H. J is the right angle, so that gets placed there. Now, G and H. We have to look back at the original triangle to determine where to place G and H. If I look back at the original triangle, G is the right angle. And when I look at the original picture, G is getting split up. The angle that's being untouched, though, is H. When I look back at the original, H is untouched because there's no altitude coming from that. So whenever I look back at the original picture, H is up here in the top. So H is going in the top of this one. H goes in the top of that one. So now H has been placed, which means G has to go there. I don't even have to think about it. Okay, going over to F, J, G. J, once again, is the right angle. And I get that from right here in the picture where J is the right angle. Okay, J is placed. Now I need to place F and G. I look back again at the original picture that I drew here on the left. F is located down here in the bottom right. So F is going to be in the bottom right here, and G in the top. Now all of your corresponding angles are in alignment. So when we go to write the similarity statement is going to be triangle HGF is similar to triangle HJG is similar to triangle GJF. Okay, and now this will help you whenever we get more involved with these problems and we have to solve proportions with it. So, moving on to the next example, example 1-2. It says identify the similar triangles in the diagram. So once again, we're looking to identify these similar triangles. The triangles in the picture are triangle. Now this angle NLM, it's not marked, but that's a right angle right there. So we have triangle NLM, that's our original. Triangle PML, and triangle PNL. Now looking at drawing these and separating them, I always think it's a good idea to separate these triangles because it's the easiest way I find to find those corresponding angles to make sure you write your similarity statement correctly. So walking through this again with you. Drawing the triangle so that way the right angle is in the bottom left. The right angle is L. We'll put N up at the top and M at the bottom. There are my other two right triangles. This one will be triangle PML. This one will be triangle PNL. The right angle. The right angle is angle P. Now, we place the right angle. Now we look back at the original triangle, and M is at the bottom here. So M goes at the bottom right in this triangle, and L goes up at top. Moving over to the next triangle. P is the right angle. Go back to the original triangle now to figure out where N and L gets placed. N is up here at the top, so N goes up at the top here. L goes at the bottom down there. So, when we write the similarity statement, we have triangle NLM is similar to triangle LPM, which is similar to triangle NPL. Looking at example 2. A cross-section of a group of seats at a stadium shows a drainage pipe, BD, that leads from the seats to the inside of the stadium. what is the length of the pipe? So here, we're trying to solve for x. Now, in order to solve for x, we have to separate these triangles and set up some sort of proportion, because when we separate these three triangles, remember, they're going to be similar. So, separating these triangles, we have triangle ABC, triangle ADB, and triangle CDB. So, draw the three triangles. Triangle ABC, putting B in the bottom left because that's the right angle. I'll put A at the top, C at the bottom right. ADB. We'll make this one triangle CDB, and this one triangle ADB. So triangle CDB, D is the right angle. We'll put D at the bottom. That's the right angle. Now C and B. C is right here in the original, so C goes in the bottom right, and B up at the top. Triangle ADB, D is the right angle. A is at the top here in the original, so A goes at the top here, and B goes at the bottom right. Now, let's fill in the lengths that we know. We know that BC is 30. So BC is 30. BC right here is 30. We know that BD is X. So BD is X and X. And we know that AB is 20. AB is 20. And we know that AC is 10 times the square root of 13. Okay, so looking at our similar triangles. So we know triangle ABC is similar to triangle BDC, is similar to triangle ADB. So now we have to write some sort of proportion with x in it, so that way we can solve for it. So, similar triangles, all of the side lengths are proportional. So, AB is to BD. AB is to BD. So, AB over BD. As AC is to BC. And I chose those side lengths because that has x in it. I could have went DB is to BC as AB is to AC also, because that also had our x in it. I only need one proportion with x involved. That is all I need. So, looking here, AB is 20. BD is x. There's our x. AC is 10 times the square root of 13. And BC is 30. Okay, 10 over 30. That reduces to 1/3. So that's 20 over x equals 1 times the square root of 13 over 3. And 1 times the square root of 13 is just the square root of 13. So we have 20 over x equals the square root of 13 over 3. From here we cross multiply. 20 times 3 is 60. And x times the square root of 3 is x square root of 13. From here, we divide by the square root of 13. And we can just get the decimal answer here. So we're going to do 60 divided by the square root of 13. And we get 16.64. So the drainage pipe is approximately 16.4 feet long. Okay, so to recap, we separate all three triangles. I wrote my similarity statement. Okay, from here, I had to pick proportions that involved x. So I did 20 over x equals 10 times the square root of 13 over 30. That's AB over BD equals AC over BC, which is 20 over x equals 10 times the square root of 13 over 30. And from there, I simply solved for x. I simplified the ratio over here, simplified the ratio, and then cross-multiplied and solved for x. Okay, let's take a look at the next example. We want to identify the similar triangles, then find the value of x. So we have three triangles here again. Triangle GDF, that's the original. Triangle EFD, and triangle DFG. So, draw the three triangles. Once again, I place the right angle in the bottom left-hand corner. All of these problems, I approach them the same way whenever I separate these triangles. So triangle GDE, triangle GDE, D is the right angle, and I'll put E up at the top and G down at the bottom. It doesn't matter where I place E and G. Looking at the next triangle, triangle EFD. F is the right angle. Now, E and D, it does matter where I place those. I go back to the original triangle. E is up at the top, so E goes at the top of this triangle. And then D at the bottom right. Triangle DFG. F is the right angle. D and G, it matters where I place those. G is in the bottom right, so I place G in the bottom right here, and D in the top. From there, I fill out what I know. DG is 8. Sorry, DG is 6. DG is 6. DE is 8. And DF is X. And GE is 10. Writing a similarity statement and asking to identify the similar triangles. So that's triangle EDG is similar to triangle EFD, which is similar to triangle DFG. From here, now I solve for x. I have to set up a proportion that involves x. Okay, so I see here that ED is to DF as EG is to DG. So ED is to DF as EG is to DG. From here, I substitute in. ED is 8. DF is X. EG is 10. And DG is 6. From here, 10 over 6 simplifies to 5 over 3, which equals 8 over X. All I did was simplify there. You don't necessarily have to do that simplification step, but I think it helps. You're working with smaller numbers now. Cross multiply, we get 5x equals 24. Divide both sides by 5, and we get x to equal 4.8. So x is 4.8. Okay, going to the next example. It says find the value of y and write your answer in simplest radical form. Okay, so once again, we're going to separate out our triangles. So we have triangle FED, triangle FGE, and triangle, I'm going to make this triangle DGE, and triangle FGE. From here, draw my three triangles. Right angle always in the bottom left corner. So, triangle FED, E is the right angle. Place F at the top, D at the bottom. In this first triangle, once again, it doesn't matter where you place F and D. Looking at the next triangle, DGE, G is the right angle. Going back to the original triangle to place D and E, D is in the bottom right corner there, so D is going here, and E is going up top. Looking at the next triangle, triangle FGE, G is the right angle. Looking to place F and E, F is up top here in the original, so F goes up top here, and E goes down to the bottom right. So looking at the similar triangles, we have triangle FED, is similar to triangle EGD, similar to triangle FGE. Okay, from here, filling in what we know. We know that FD is 15. We know that FG is 4. We know that FE is Y. We know that GD is going to be 15 minus 4, which is 11. So we know GD is 11. And that's all we know. So from here, now we set up a proportion to solve for y. So we need to use ratios that involve y. We know that FE is to FG. So FE is to FG as FD is to FE. From here, we fill in what we know. FE is Y. FG is 4. FD is 15. And FE is Y. Now we cross multiply. Y times Y is Y squared. 4 times 15 is 60. From here, we take the square root of each side. Square root of 60, we can simplify that. That is the square root of 4 times the square root of 15, which is 2. So y equals, in simplified radical form, 2 times the square root of 15. Okay, your assignment for tonight, I'm going to stop there for today. Your assignment for tonight is 7.3, practice B, numbers 1 through 9. Now, keep in mind, please remember, you want to make sure that you are separating those triangles whenever you are doing this and looking for those similar triangles and those corresponding side lengths. So once again, 7.3, practice B, numbers 1 through 9.